effortless. Put on my boots and a lily white dress. A million words, but how to express what I'm feeling when I see you. You flash a smile, I'm like, is this happening? I look your way and then of course drop everything. You walk over and ask if I'm alright. Hey, whatever it takes to break the ice. Don't walk away, there's more to say. I just need the courage to let you know what's on your mind. Like every time you pass by, something just feels right.
Yeah, initially chat seemed to be disabled, but once I refresh the page, then chat is enabled again, right? So try refreshing the page, or if you're using an app like mobile, you can just close the app and then try opening it. Chat is enabled.
Maybe a pickup line, but either one of those is just a waste of time. I need a better way, I need some inspiration, something that better explains all my motivation. To meet you, know you, and be on your mind. I have to, but how do I put this right? Don't overcomplicate, just say hi, or whatever it takes to break the ice. Don't walk away, there's more to say. I just need the courage to let you know what's on my mind. Like every time you pass by, something just feels right. Not everything is energy locked up, that's ready to scream and shout. I won't make the same mistakes twice. Ready to shake up and break the ice. Do you have a roadmap that I can try? 'Cause I think I just got lost in your eyes. I have to tell you, I really want to. Whenever I look in your eyes, I won't make the same mistake twice. I'm ready to shake up and break the ice. Don't walk away, there's more to say. I just need the courage to let you know what's on my mind. Like every time you pass by, something just feels right. Not everything is energy locked up, it's ready to scream and shout. I won't make the same mistakes twice. Ready to shake up and break the ice.
So, hi everyone, a very good morning. I hope you have the chat enabled, right? So, today we're going to have textbook discussion on the topic direct filling gold, and the reference book is Phillips. So, also I'm going to refer a few other books and give you additional points in the process, right? So, we'll start off with our key terms, right? So, before starting off, once again, a very good morning. Hi, Anobali, Megha, Shrish, Bernice, Purvel, Regina. Hi. A very good morning. And Purvel, I think it's evening for you, right? Regina, it's 2 o'clock in the morning. Okay, so we'll start off with the key terms. So coming to, I mean in the old edition, even in the latest edition, we have these key terms at the beginning of the chapter, right? So we'll just go through some of the key terms and then go through the literature given in your latest edition of your Phillips. Right, so first we have the term annealing. So annealing is a controlled heating and cooling process designed to produce desired properties in a metal. Whereas cohesiveness, we have another term called as cohesiveness, where it represents the forces of attraction between molecules of similar kind. Whereas adhesiveness, or we have something called as adhesive, where there is attraction between, or the propensity to have attraction between different molecules altogether. So cohesive is pertaining to the force of attraction of atoms or molecules of a single phase. And then we have cold welding. So cold welding, as we discussed in one of the live sessions this Monday, it's a process of welding two metal components at a normal room temperature without any heat or pressure, hence it's called as cold welding. So process of plastically deforming a metal, usually at room temperature, accompanied by strain hardening. And then we have compaction or condensation. So compaction or condensation is a process of increasing the density of a metal foil, pellets or powder through compressive pressure. By the way, through condensation, we can achieve a density of 14 grams per centimeter cube. In fact, gold is considered to be having a greatest or highest density, which is approximately 19.6 grams per centimeter cube. And then you have something called as degassing, desorption. So degassing is nothing but process of removing gases from a solid, whereas desorption is process of removing molecules that have attached to a surface by a physical phenomena rather than by a chemical phenomena. So next we have ductile. So ductile is ability to draw into thin wires or able to be elongated or thin plastically without fracturing. And malleable is to be hammered, ability to be hammered into a thin sheet without fracturing. And by the way, we'll discuss the properties, in the context, we'll discuss this ductility and malleability when you're going through the properties. And non-cohesive, it's pertain to an inadequate force of attraction between molecules or atoms of single phase. And welding is a process of fusing two or more metal parts through application of heat, pressure, or even both, with or without a filler metal to produce a localized union across an interface between the parts. And then work hardening. So process in which hardness of a metal increases during cold welding. This phenomena is also called as strain hardening, which is usually accompanied by increase in strength and hardness and decrease in percentage elongation. Also, we had one question pertaining to this, right? So these are some of the key terms and my personal preferences before starting any chapter. So it's always advisable to go through the key terms and then go ahead reading the entire textbook on that particular chapter, right? Now, let's go through, I'll be following the latest edition. So I have both editions with me, the 11th edition and the Southeast Asia or the latest edition. So you can follow any one of them, but latest edition, it seems to be more concise, right? So you'll be following the latest edition, right? So page 430, page 413. Yeah, hi Ramesh. Okay. Okay, Purul. Time is 5 p.m., right? So Regina, it's 3:15. Good. Okay, then. I don't know how you guys really manage sleep. Right. So you can see that in the introduction part, it's given that, see, gold, as you all know, it's one of the most pure and noble metals ever available. It's considered as noble metal because it doesn't react with any chemicals unless until we have some acids like hydrochloric acid. Gold doesn't normally react with all these substances, right? It's considered to be inert material. Hence, it has so much value. And also we have gold. In the electromotive series, if you observe all the list of metals, gold is present somewhere on the top, or noble metals are present somewhere on the top. So when you have in the oral cavity, or for example, you have two metals like an amalgam, or you have this gold restoration. So gold, since it is present on top of the electromotive series, it acts as a cathode, whereas silver, it acts as an anode. All this will be discussed in tarnish and corrosion, right? So already I think that was a theory class which we had taken previously, but you have these noble metals present on top of the electromotive series, right? And also, pure gold is noblest of all dental materials, rarely tarnishing and corroding in the oral cavity. It is active, it is inactive chemically, and is not affected by air, heat, moisture, and most solvents. And at room temperature, two thin sheets of atomically clean pure gold can be welded under pressure. So this is the unique property we have with gold. So we can weld gold layers or gold atoms. It's possible because of the interatomic interaction that's presenting between the gold atoms, right? So for that, the most important thing is the layers of gold have to be atomically pure. It means there shouldn't be any dissolved gases present or it should not be contaminated. That's very, very important, right? Now, the procedure through which we have this compaction or cold welding. So this is cold welding where welding is done at room temperature as we already discussed. And The hardness values of gold is very important. It's given that pure gold, it's very soft. 24 karat gold is very soft, it's brittle, and the hardness value is 22 Vickers hardness number. So pure gold is very soft, that is 22 Vickers hardness number. And during the process of work hardening or strain hardening, during the compaction of gold in the cavity, the hardness value exceed that of type 1 gold and almost approach to that of type 2 gold alloys. We have this type 1, type 2, 3 and 4 gold alloys, right? Wrought metal alloys. So when you have this strain hardening done inside a cavity, the gold hardness increases, exceeds that of type 1 gold, which is 50 to 75 Vickers hardness, and approaches to that of type 2 gold, which is approximately 90 Vickers hardness. I'll just read out the statement directly. After work hardening, its hardness 52 to 75 Vickers hardness number is equivalent to and may exceed that of type 1 gold alloy, which is 50 Vickers hardness number, and approaches that of type 2 gold alloy, which is 90 Vickers hardness number. And as I said, you should have atomically clean gold layers, and this is called as cohesive gold. So it has this property of cohesiveness. But when you have these adsorbed gases, etc., then it loses its cohesiveness. And also, by intention, we add a layer of ammonia so that during transport or during storage of gold foil or any layers or any type of gold, the gold doesn't adhere or have this adhesion or cohesion for that matter between different layers of gold. To prevent that, we intentionally add a surface layer of adsorbed ammonia gas, and this is called as non-cohesive gold, right? Yeah. So non-cohesive gold, it has to be dissolved or annealed or heated before usage so that we obtain that cohesiveness in atomically clean surfaces. That's the concept here, right? So that's the introductory part given here. Now we have different forms or different types of gold. So the classification and the synonyms of gold are very important. I mean, you can refer the previous edition of a detailed classification in the sense they've given a list where they have mentioned that gold is available in three formats. So one is gold foil, the other one is electrolytic precipitate, and the third one is granulated gold. So in gold foil, again we have it's available in form of sheets, ropes, cylinders, laminated foil, platinized foil. And in electrolytic precipitate, we have matte gold, matte foil, and also gold calcium alloy. And we have this granulated gold or encapsulated gold powder. You can just go through this classification. It's very important, and also you have some synonyms for each of the term. Like for example, sheet, a gold foil is also called as fibrous gold. Electrolytic precipitate is also called as crystalline gold. And granulated gold is also called as encapsulated gold powder. So even the synonyms are very important to remember and understand. And I'm sorry, just 1 minute, right? Okay. Now, we'll just go through each of this classification, each of this type of gold, and then see what important points we can grab from the literature. So, different forms of direct filling gold. So, I'm following again the latest edition, page 413. So, direct filling gold is supplied in three basic forms: foil, electrolytic precipitate, and granular gold. So foil is also known as fibrous gold, F and F. Foil, fibrous gold. And electrolytic precipitate, you have this crystalline gold. And granular gold is also called as powdered gold. So they all can be cold welded. However, the efficacy of restorations made from these materials is adversely affected by improper handling, contamination, etc., with the exception of platinized gold and alloyed electrolytic precipitate. So platinized gold we add platinum, alloyed electrolytic precipitate we add calcium 0.1%. With the, apart from these things, the rest forms of the gold which are available, like matte gold, cylinders, sheets, etc., they are 99.99% pure. And you know what? There are only two metals mostly used in the industry in their pure form, 100% pure form. One is gold, which is used in its pure form, and the other is titanium. So only these are only two metals which are used in their pure form in our profession, in the industry, right? Except for the platinized gold and alloyed electrolytic precipitate, the rest forms of the gold The chemical purity of most types of direct filling gold is 99.99 or even higher. Okay. Next, before going into these different types of gold and all, we'll just go through the properties, right? Properties, first we'll deal with properties and then we'll go through the different types of gold available. So properties are quite interesting. They're really interesting and we thoroughly enjoyed when we were discussing in the theory class. So as you said, gold is a noble metal, so it doesn't react chemically with any other substances and it's considered to be noble and it's considered to be very pure. And you know what? Ductile and malleable. Gold is considered to be the metal which is having greatest or more ductile value. For example, 1 ounce of gold, approximately 29 grams, can be drawn into a wire of 100 kilometers. It shows how ductile the material is. 1 ounce of gold, approximately 23 grams, 23 grams can be drawn into a wire of approximately 100 kilometers length. And so it's most malleable and most ductile material available ever. And coming to its malleability, it can be beaten or compressed into thin sheets, and the sheet thickness can be reduced to as low as 0.00013 mm. Just imagine. 0.00013 mm. So we can almost make the gold layer as it can be like when you just watch it under the light, it appears almost transparent. So it's so thin, it can be beaten to a very, very thin shade. So it's most malleable, it's most ductile. And also, it is reduced by rolling to 25 microns or less, and it's manufactured for dental use. You can just make a note of it. It's given in the old edition. And it's manufactured for dental use. 25 microns is the starting thickness for processing further to a sub-micron thickness. And coming to hardness of coal, we have already dealt with that. Pure gold is soft. It is having a value of around 20. And is it 20 or 25? It's 22. Pure gold is soft. Hardness value is 22. And when coal welded and when a work hardened, its hardness increases or exceeds to that of type 1 gold and approaches to that of type 2 gold. So type 1 gold approximately 50, type 1 gold alloy, right? So type 2 gold alloy. So type 1 gold alloy, the hardness value is 50 to 75. Type 2 is almost 90. And with work hardening, the hardness strength increases, but the percentage elongation decreases, which is approximately 12.8, which is considered to be high. And the density, gold is the material which has greatest density. So often we assume that, so density, is it an advantage or disadvantage? If you have high density, do you think it's an advantage or a disadvantage? Density, if you have, like when it is high, we feel like more material can be incorporated in a given volume of cavity, so the material will be having more strength when the density is more. It's true, but when the density is high, you have to incorporate more material, the same reason, but from the economical point of view, it's not so economical. When you're incorporating more amount of gold in a single in a given volume, obviously you'll have to spend more, you have to use more gold, and gold is very costly, as you know, right? So it has both advantage and disadvantage in economic standpoint. So it has one of the highest densities of all elements, approximately 19.3 grams per centimeter cube. And here is one important point. When placing gold in a cavity, the density of 19.3 is never achieved. It's because when you condense the gold, we are doing it, right? So humans are doing it. So there are many manual errors which can creep in, and there can be void formation. We'll try to keep the voids to the minimum extent, but in spite of all the things, density clinically, if you observe the table, you'll understand what I'm trying to say. You observe the table 17.5, 17.5, where the density seems to be 14, 50, or in and around 14, but not 19. That's because of inherent void formation, right? And we also have like few disadvantages were mentioned, like it's like in the sense it is yellow in color, so it can be considered anesthetic by some patients, and it cannot be used in high stress bearing areas, and also it's very costly. So these are some of the disadvantages. So the properties are very, very important, right? So you should know the density value, you should know like what is malleability, what is ductility, and also most importantly, the hardness value, right? Now we'll just go through some of the different forms of granite filling gold, starting with gold foil. I hope you guys are able to follow, or is it like I'm singing a song and you feel sleepy? Exactly, Buenos. It's a disadvantage as more material has to be used. Yes, Nidhi, a very good morning. Avnish, it's your first morning session. Great to hear that. Morning sessions, you will have like very few participants since it's a morning session. We're all night owls, more or less. You can see the contrast. Yesterday it was like 60 or 70 members live. Now it's around 14 or 15. Yes, having more density is an advantage, but it's a disadvantage from money point of view. That's what I'm trying to say. Yes, Regina, you're not here. Hi, Pooja. Very good morning. Yes, Abhishek. Yeah, Devna, finally you're attending the morning session. Welcome and a very good morning. Good morning, Abhishek. Okay. Right. So we'll proceed with different forms of gold. First, gold foil, also called as fibrous gold. So gold foil is provided in sheets. It's also available in form of pellets, cylinders, ropes, platinized gold, laminated gold. Laminated means different foils placed together and compressed. Laminated means different layers. And you have this platinized gold where platinum foil is sandwiched between two gold foils, right? So platinum is added to increase strength and wear resistance. Now, platinized gold, okay, we already discussed, right? Platinized gold is a laminated structure with one sheet of platinum foil between two gold foils. And the objective of adding platinum is to increase the hardness and wear resistance. And you have this number of gold. You have the standard number 4, standard number 3, etc. Standard number 4, so this is very important. 4 or the number indicates the weight of the foil. This is very important. This is not the dimension or something. The number indicates the weight of the foil, right? So standard number 4 gold is supplied by dimensions 4 into 4 inch or 100 into 100 sheets where the weight is 4 grains. 4 grains means approximately 0.259 grams. And the thickness of this number 4 sheet is 0.51 microns. 1000 microns, 1 mm. It's 0.51 microns. And the numbering system refers to the weight of a standard sheet. So this is very important, right? So number 4, when I say standard number 4 gold foil, the dimensions are 4 into 4 inch or 100 into 100 mm. And also we have the weight which is 4 grains. So it's approximately 0.259 grams and the thickness is 0.51 microns thick, right? And also only for number 4 size is mentioned here in this newer edition. In older edition, we also have number 3 gold. So number 3 weighs 3 grains, where the weight is 0.194 grams and the thickness is 0.38 microns. You can just make a note of it, right? Yeah. And these are available in 100 into 100 gold foil sheets. Similarly, we have number 20 grains, 40 grains, 60 grains, 90 grains. And remember and note it down, number 3 foil is used in electrolytic and powder products, which we'll discuss later. So you have this powder which is placed in the sheets and then rolled in form of cylinders, ropes, etc. So we use number 3 gold foil there, right? Yeah. So that's about the numbering system of gold foil. So I hope it's clear. And during storage, gold foil, like most other metals, attracts gases. It doesn't chemically react, but it attracts gases to its surface from the environment, and any absorbed gas film, which you have this adsorption of gases which prevents cohesiveness or prevents intimate interaction or fusion of different components of gold during welding. So care has to be taken to heat the foil or heat the gold to dull red in color, so that these adsorbed gases or dissolved or desorption happens. And to prevent this contamination of gold during storing and during transport, the manufacturers intentionally add a layer of ammonia on surface of gold, making it non-cohesive, right? So non-cohesive gold is something which doesn't which doesn't have this cohesiveness, and the gas used is ammonia. So before using, we have to heat them to remove that ammonia gas so that the cohesiveness is restored back again. Yeah. Now, so that's about gold foil, right? Goal hardness is directly proportional to which factor? Factor in the sense, what is the context, Avinash? I didn't get it. So obviously, with work hardening or strain hardening, there will be increase in gold hardness, right? So next we have this electrolytic precipitate gold, also called as crystalline gold. These synonyms are very important, right? So we have another form of direct filling gold, which is microcrystalline gold powder formed by electrolytic precipitation, where we have this sponge gold or matte gold. Remember, this electrolytic precipitate is sandwiched between sheets of gold foil and formed into strips, and the sheets of gold foil used here are number 3 gold foil, which we discussed previously. It's not number 4. So number 3 gold foil is used as it's used as a carrier to carry this electrolytic precipitate or the granular precipitate, which we're going to discuss later. So another form of direct filling gold, microcrystalline gold powder, formed by electrolytic precipitation, which is sandwiched between the sheets of number 3 gold foil and formed into strips. It's also called as matte gold, sponge gold, or crystalline gold, right? And the powder consists of dendritic crystals approximately zero point 0.1 mm in length. Make a note of it. The length of these crystals is zero point 0.1 mm. It's not microns, it's millimeters. This form of gold can be cut into desired shape, and mainly this electrolytic precipitate gold is used for filling up the internal bulk of the restoration, right? You have a bulk of class 1 cavity, for example, the main entire bulk is filled up with this electrolytic precipitate. And also, matte gold made of electrolytic precipitate can be alloyed with calcium 0.1%. The role of calcium is to increase hardness by dispersion strengthening, right? So gold strength can also be, hardness can also be increased by adding platinum and by adding calcium. So Avnish, you have also these external factors which are being added and incorporated into gold to increase their hardness, platinum as well as calcium. Now, that completes our electrolytic precipitate gold or matte gold, sponge gold, or crystalline gold, right? So we're done with gold foil and electrolytic precipitate gold. And finally, we have granular gold or powdered gold. So gold powder can be obtained through electrolytic precipitate, that we have done. Now, also through chemical precipitation or atomization, we can form or we can produce granular gold or powdered gold. And these powders, they're difficult to carry, right? You just can't carry powder, and we can lose powder in the process. So they're added to wax and they're cut into small pieces. So these, to prevent agglomerates from disintegrating, the atomized and chemically precipitated powders are first mixed with soft wax to form pellets, and these pellets are cut into cylindrical shape of several diameters and lengths, and heating to burn wax away is mandatory before insertion into the cavity. And also we have the size of the particles of granular gold, which is maximum of 75 microns, and the average size is 15 microns. So you can see in the old edition it's mentioned, but not in the new one. So the maximum particle size is about 24 microns for atomized gold, and the average size is 15 microns. Whereas in case of your electrolytic precipitate, it's 0.1 mm, it's 15 microns average in case of granular gold, and the maximum size can be up to 74 microns, right? Okay. So we're done with granular gold and powdered gold. So we have three types of gold available based on the availability. We have foil, electrolytic precipitate, and granular or powdered gold. Now, preparation of direct filling gold for restoration. So we have this process of annealing, desorption, degassing, or heat treatment. We have different synonyms, but the most appropriate term to be used here is desorption. So, prior to placing a direct filling gold in cavity prep, the dentist heats the material to remove a protective coating or wax introduced by manufacturer. Individual pellets can be held over an open flame, so we can heat the gold either by holding the pellets using a tweezer or stainless steel points or by placing gold on a tray and then heating it over the flame. And the source of flame can be alcohol, it can be your electricity. So we have different sources altogether available. Now, individual pellets can be held over an open flame of pure alcohol or group of pellets or other gold forms placed on an annealing plate which is heated by electricity, right? And this step is commonly called as annealing, heat treatment, degassing, but the most appropriate term is desorption because there is absorption, not absorption, but adsorption of the gases onto the surface. So we're trying to desorb those gases. And you know what? Powdered gold, the duration of degassing is very important. Powdered gold pellets may take 15 to 20 seconds because we have wax incorporated, so we take more time. We need to take more time to eliminate that wax residue. But gold foil pellets or electrolytic gold pellets may require only 1 to 2 seconds, and you have to heat it till the gold exhibits a dull red glow. Dull red glow is an indication that adequate desorption or adequate heating is done. Yeah, hi Saida, very good morning. So we have to handle the pieces of gold with a stainless steel point or similar instruments so that there won't be contamination, right? And we have something called as underheating and overheating, which is very, very important. Just make a note of these points. Underheating can compromise cohesiveness or cohesion between segments. If you underheat it, there won't be cohesion because the surface gases are still intact, right? So underheating can compromise cohesion between segments. But what about overheating? Overheating can lead to excessive sintering or fusion of gold particles, and possibly there can be contamination from the tray or instruments or even flames. So there can be contamination and there can be sintering of the particles. So what happens when this happens? There can be difficulty in condensation of gold in a cavity. There can be incomplete cohesion again, embrittlement of portion being heated, or poor compaction characteristics. So either underheating or overheating are not indicated, or they are considered to be disadvantages from the physical properties point of view or from the gold properties point of view. And also the fuel which we use, it is either alcohol or gas. Alcohol is preferred because with gas again you can have impurities, and even in alcohol, methanol, pure methanol or ethanol without colorants have to be indicated. And the advantage, when you have this flame desorption, you can either place the gold foil over a flame or we can use a tray, right? So when you compare both, flame desorption is advantageous. So advantage of flame desorption includes selection of piece of appropriate size and desorption of only those pieces which are being used and reduce exposure to contamination, right? So that completes a preparation of direct filling gold for a restoration. And then finally, we have compaction of direct filling gold. So compaction of direct filling gold, we have two terms called as wedging and cold welding. So cold welding we have already discussed in detail. So what is this wedging? So wedging refers to pressurized adaptation of gold form within the space between the tooth structure walls or corners that have been slightly elastically deformed. So what is wedging technique which we do in a class 2 case? We place a third material between two tooth structures, right? So we're trying to wedge one third substance between two teeth or natural teeth. So we're trying to wedge. So similarly, wedging here is nothing but trying to fill up the gold between two walls, and here we have three terms: tie formation, banking, and shoulder formation. So tie formation is nothing but having a transverse bar of gold or adding gold. If I assume that you're staying in a room, so assume that this room is a cavity. We have line angles and point angles. So we have 2 point angles. When you try to connect two point angles with the transverse bar of gold. We just place gold and try to connect those two point angles with that gold and try to condense it. That's called as tie formation, right? That's called as tie. And then you have something called as banking. Banking is nothing but you can see the wall behind me. So assume that it's a cavity. So from the floor towards the cave surface margin, if you add up the gold along the wall from the floor towards the cave surface margin, that's called as banking formation. And banking has to be done simultaneously for all the walls in a cavity. And finally, you have shoulder formation. Shoulder formation is nothing but connecting the opposing walls in a cavity with gold. So these are some of the steps which we follow. That is tie formation, banking, and shoulder formation, which is again very important, right? So wedging refers to pressurized adaptation of gold formed within the space between the two structure walls or corners that have been deformed elastically. And for cold welding, you should have atomically clean condition, right? All that we discussed before. Now we have condensers, size of condenser tip, compaction method. We'll just go through them in brief and see what important points we can grasp. Condensers, they can be straight, curved, angled, round, square, rectangular. Tip can be smooth, serrated. It can be flat surface or convex faced, and the condenser tip has to be kept atomically clean. And the size of condenser tip, it's again very important. So similar to that of amalgam, you have 1 mm condenser tip and 2 mm condenser tip. So which one do you think delivers more force? So 1 mm condenser tip delivers force 4 times more than 2 mm condenser tip. So surface area inversely proportional to the force being delivered. I'll just go through that, which is given the late. I mean, the previous edition is mentioned very clearly along with values, right? So I'll just go through that and read the same, which is given. Yeah. Old edition page 554. The size of condenser tip is an important factor in determining the effectiveness of compaction, and the force distribution to the goal depends on the area of point. For example, a given amount of force is distributed over 4 times as much area for a 2 mm diameter tip as for 1 mm tip. In other words, the pressure is 4 times as great with 1 mm condenser as with 2 mm condenser. Conversely, it takes 4 times much force to fully compact the area. That's fine, right? So when you compare a 1 mm tip with 2 mm tip, so 1 mm tip delivers force 4 times more than 2 mm tip. And for compacting gold or for condensing gold, smaller condenser tips are indicated to achieve desired compaction at lower forces than those that might damage oral structures. So that's the exact point mentioned in the latest edition. Now coming to compaction method, we can use either hand pressure, electronically can be done, or it can be done using pneumatic pressure, or it can be even done with spring loaded, etc. So hand malleting or mechanical devices like spring, pneumatic pressure, electronically, we can do condensation. Condensation is very important, so we have something called as cold welding or work hardening. So condensation has to be given due importance. And we have something called as stepping. Stepping is nothing but you place gold as one increment here. And when you're placing and condensing the next increment, you have to step the previous increment, right? So stepping has to be done. So once you place this increment again, you have to step this increment. So you have to follow this stepping pattern. It means when you're trying to condense a particular layer, even the previous layer or previous increment has to be stepped or condensed simultaneously. So that's called as stepping. Condenser penetration. Oh, that's condenser penetration. Where is stepping given? It's not mentioned. I think it's mentioned in the previous edition. Yeah, it's given here at the end. The condenser tip must be stepped in a controlled overlapping pattern, right? In a controlled overlapping pattern. Also, you can see the depth of condenser tip is also very important. It's 0.2 to 0.3 mm. If the increment which you have added in a cavity is 0.5 mm, the depth of penetration of a condenser tip should not be more than 0.5. It should be less than 0.5 mm. So condenser penetration should be less than the thickness of each segment that is compacted, and the depth of each cold welded mass is usually between 0.2 and 0.3 mm. That's it. Just make a note of that value, that would be sufficient. And next page, 415. A small amount of excess material is provided to ensure proper contour. We can trim off excess with sharp gold knives, files, abrasive discs, etc. That's fine. Physical properties, page 415, we have already discussed in detail, right? Yeah. So we have one property mentioned here, which is called as transverse strength or bending strength, which is nothing but which represents compressive, tensile, and shear. So we can see that transverse strength of different forms of gold, it's around 160, and for you have matte gold, powdered gold around 160, but for gold foil it's around 290. So this transverse strength or bending strength reflects compressive, tensile, as well as shear forces, right? So this transverse strength is an indicator. It's an indirect indicator of cohesive strength. It means the more the cohesive the material is, the higher the bending strength it has, right? So just underline that point. Bending strength represents an indirect indicator of cohesive strength, right? And hardness indicates an overall quality of compacted gold. Just underline those points, right? Yeah. Now let's move on to the final part of this textbook discussion, that is direct gold restoration advantages, disadvantages, and indications. So the use of direct filling gold is generally limited to areas where they simply fill the space. In other words, they shouldn't be used in stress-bearing areas, such as pits and small class 1, 2, 3, 5, and 6 restorations, and for repairing casting margins, and there is no pulpal irritation, only a minimal pulpal response is elicited, and high quality, this is very important, high quality direct gold restorations can be ensured by having these four factors. The first one is selecting the appropriate gold form for that clinical use. For example, if you're trying to fill up the bulk of the restoration, then you have to use electrolytic gold, right, as mentioned previously. So selecting the appropriate gold form for each specific clinical situation. Material is used only where it is indicated, not in high stress bearing areas. So case selection is very important, and a perfectly dry and clean field has to be obtained. There shouldn't be any contamination, and the material is manipulated properly with correct instruments. So these are the four factors which govern in getting a proper output. So in order to have this high quality gold restoration, we need to have these four factors, right? Dry field should have proper instruments. Case selection is very important, and more last but not the least, the gold form to be used in appropriate clinical context, right? Now, the chief disadvantages of gold foil. So it includes, as we discussed initially, a low luster, high thermal conductivity because it's a metal, and technical difficulties. It's technique sensitive in order to obtain a high dense restoration. And at the end, it's mentioned that you have this American Academy of Gold Foil Operators who have these study club discussions happening all over the world, including India. In Chennai, they started recently, and also they post their website. I mean, they mentioned their website also, right? It's quite interesting. You can go through the cases. And note that the restorations were placed under rubber dam isolation. The use of rubber dam is essential to minimize the risk of contamination. So rubber dam has to be used. It's mandatory. So this completes a direct filling goal textbook discussion, right? So since I had limited time, so it was 12:30. I slept at 1:30 last night. I had to wake up again at 4:45. So due to time constraints, I couldn't frame questions from this topic. So today evening, when you have this textbook discussion of these dentin bonding agents, we'll try to have MCQs both from the direct filling gold as well as from dentin bonding agents after the textbook discussion today, right? So today, 7:30 or 9 p.m., I'll let you know through WhatsApp and also through mail. So you have any questions, you can drop them. And most importantly, this is a memory-based topic. So a lot to memorize. So make sure that you focus when you're studying with least distraction possible from the external environment. So memory-based topic, I'm quite sure I've read this topic n number of times, but even then I still have this confusion like which type of gold is called as what. So we all have that confusion, right? So memory and recall were very important. So make a note of all the synonyms, make a note of all the key points, and try to memorize them. If you study and leave it again, you might forget it. Obviously, we'll forget things, but for you to remember that in a very limited time, you have to make notes of these things. It takes hardly 10-15 minutes or maximum of 30 minutes, which is worth investing, right? So that whenever you forget, you just go through, you'll just have that in mind at least till the date of exam. Okay? And thank you, Nidhi, for giving me the pictures of this particular chapter yesterday, or else I would have been following a old edition. Bernice, we have already covered this classification of type 3 and type 4 gold alloys in our prosto and also in our dental materials. You can go through wrought metal alloys. We have this classification based on gold content. 75%, less than 75%, less than 25%. We have some criteria as per ADA. You can go through the one of the videos in YouTube, in our e-classes, not YouTube, I'm sorry. In e-classes, we have this wrought metal alloys, noble metal alloys. We completely covered all of them. So based on the gold content, we have this type 1, type 2, type 3, and type 4. Obviously, when there is more gold content, the hardness is less. Type 1, it's mentioned 50 to 75, right? Type 2, it's around 90. Type 3 and type 4, we have more of base metals, right? You can just go through the video. Yes, Devana, direct filling gold is called as direct filling gold because it's not placed indirectly. We have indirect gold restorations as well as direct gold. Direct filling, you are directly doing it in the patient. It's a direct restoration, it's not an indirect restoration. Gold can also be used for indirect restorations if you know. So it's called as direct filling gold. It's done child side. And I hope you answered that question, Devana. Regina, I didn't get you. If you make metal fused ceramic crown, in which cases we should go for gold? I hope we have discussed the indications of gold restoration, right? Direct filling gold. Yeah. Okay. Yes, Purvil, you can join our WhatsApp group. We have our WhatsApp update group. You can drop a mail at proudtobedentist@gmail.com. I'll send you the group link. We're not going to have any discussion over there. We'll be just posting you the updates. But for discussion's sake, we have another group called a study club. You can just drop a mail for more details. Regina, it's nothing like that. In fact, you know what? I've enjoyed both. So old edition, you have a lot of information, but new edition, they've concised it. I don't know the reason why, but yes, definitely. Sometimes it's like even the old edition is of old is gold. You can say old is gold. Vivo X5. I know Vivo smartphone. Right. Yeah, we have in vitro, in vivo, and ex vivo studies. Right. Okay. So now we are coming to end of discussion, and the number is increasing now. Maybe 6 o'clock. So it's time that most of you will be getting up. I just wanted to postpone today's session, but somehow I will try and make sure that we stick on to the schedule, right? Okay, then we'll conclude. So, a very good morning once again, all of you. Glad that you all joined us live early in the morning, in spite of it being late last night. It's around 11:15, I guess, right? So, we'll see you again today evening with more textbook discussions and more MCQs. And also, we're doing some recorded videos, and we're done one recorded video. Due to time constraints, we haven't uploaded that. So we have one recorded video on MCQs discussion in dental materials. So I chosen few multiple choice questions for discussion. You'll have them in your e-classes, and we'll update you via mail this morning or as soon as possible, right? Yeah, 11th edition is an old edition. Okay. Right. So see you all again today evening. So hope you're all doing good. No negativity, and no negativity with negative marking. It has to be only positivity, and it is definitely going to have a positive impact in all of your result, right? So all the very best, and okay, see you again today evening. Bye. Take care. Love you all.